Hi guys, welcome to our summer reading program, STEAM Ahead program with the St. Louis Obispo Children's Museum. My name is Miss Margaret and I am with the County of San Luis Obispo Public Library. This project is a program of the County of San Luis Obispo Public Library, supported in whole by the U.S. Institute of Museum and Library Services under the provisions of the Library Services and Technology Act, administered in California by the State Librarian, which means, in short, that we were able to get grant funding to pay for this program through the California State Library. So we're very grateful to them. And we have the wonderful Miss Lexi from the St. Louis Obispo Children's Museum, who's going to be leading our program today. So I will go ahead and mute myself and turn you guys on over to her so we can start our project.
Hi everyone, I'm Miss Lexi from the San Luis Obispo Children's Museum. Thank you so much for joining me today. We are going to be doing a science experiment about ice and how the different properties of water change when you add different substances. So I'm going to show you guys all the materials that you'll need today. Okay, so what you're going to need, you can mostly find around the house. If you have the box, you should have all these materials ready to go for the most part, but even so, there'll probably be a couple of things that you'll have to get from your kitchen. So first, we're going to need some string today, and you can use kind of any type of string for this. It doesn't have to be super specific. It doesn't have to be red. You can get any color. Even if you have yarn or something that's a bit thicker, that should work as well. So just grab whatever you have for that. You're also going to need some salt and an ice cube. And then finally, you're going to need a glass of nice cold water. Okay, so go ahead and get all your materials and then we will get started. So for this experiment, it's pretty simple. We're going to start by taking our ice cube and putting it right in our glass of water. And as you'll see, it'll float to the top. For the next step, we are going to take a little bit of our string, so you can just have an adult help you cut it off. And you're going to lay the string across the top of the glass and kind of press it down into the ice cube. You might not want to stay, but that's okay. Just make sure it's laid across the ice cube so you have some contact there. Next, you're going to grab your salts and go ahead and take a nice big pinch of it and sprinkle the salt on top of the string where it's laying on the ice cube. And you can go ahead and do a good amount of salt. Maybe press down your string a little bit more. What we want is some contact between the string and the ice. Okay, and now we wait. So we're going to wait for about 10 seconds for the reaction to occur. What's happening right now is the salt is actually changing the freezing point of water. So water normally freezes at about 32 degrees Fahrenheit. When you add salt to the water, it actually lowers the water's freezing temperature. So now the water has to get much colder than 32 degrees to freeze. So when we put the salt in the ice cube, it drops that freezing point. So the ice cube is going to melt a little bit. And then as the salt kind of falls off the ice cube and into the water, it will diffuse. So there's less salt and water mixed together right where we have the string. And that means that the freezing temperature goes back up to 32 degrees. So what we should see happen is a nice thin layer of ice over the string. So the ice cube will actually be stuck to the string. And it should be about ready. So we're going to go ahead and try it out. Grab the two ends of your string. Oh, nope, not ready yet. Okay, we're going to try it again. Okay, put your string back and add the salt. I got a little too excited. I got ahead of myself. So we'll give this a little bit more time and then it should work. So what we're waiting for is the salt going onto the ice, melting it, and then diffusing into the water so that that freezing point goes back up and the little puddle that you see in the ice cube that's melting because of the salts that's going to refreeze. So we have to let that whole process happen before the experiment is done. So that's why we have to wait one more time. So if you've ever been anywhere snowy, you've probably seen salt used in a similar way to melt ice. So we sprinkle salt on the roads and the sidewalks when it snows so that the ice melts and the roads don't freeze. And that's for the same reason, because the salt gets in the way of the water molecules, preventing them from being able to solidify and freeze up into an ice cube. So this keeps all of the roads that have salt and the sidewalks that have salt in snowy areas free of ice and snow. Okay, we're gonna try this again. Go ahead and grab the ends. There we go. Oh, it won't last forever because it's just a tiny piece of ice across there holding it up, but that's our experiment for the day. I wanted to get in a little bit more into why this happens. So like I said before, the salt changes the freezing point because it blocks the water molecules from sticking together, which is what they need in order to solidify and form an ice cube. So the salt is just getting in the way of this process. It's stuck in the middle, so the water molecules can't come together. This is also why the ocean doesn't freeze very easily. So in most places, the ocean is just too salty to freeze because it doesn't get cold enough. Only really, really cold areas like the North and the South Pole get cold enough for the ocean to freeze, for the reason that you saw today when we went ice fishing. So that's our experiment. If anyone has any questions, I would love to talk more about it.